Okay, so just a little bit more practice, and I'm not saying this is going to be a free response for your test, but it's a possibility, and it's just more free response type problems to review. So here it says picture to the right is the graph of the first derivative f prime, and it says that, but just make sure that you really, really know that this is the graph of f prime, and you're not thinking about it as being f of x. It also says that f of -1 is 2. That's nice. I have a point. And I know that this f of x is concave down, so I know some information here about the graph. It says approximate the value of f of -0.9 using the equation of the tangent line. Okay, so before I answer any of the rest, if it's asking me to use the equation of the tangent line, I need to have the equation of the tangent line. So on this, I need to know y minus y1, because to find the equation of the tangent line, you need a slope and a point. I have a point right here. So this is y minus y1 is equal to m times x minus x1. So I'm showing you just first that the point is coming up from here. So this is my x1 value, it was minus negative, and then here is my y1 value. My m is my slope of the tangent line, and that would be at -1. So f prime of -1, my slope of my tangent. If I go over this graph to -1, I can see the slope of the tangent line is -3 because it's given to me. So -3. So I'm gonna write y minus 2 is equal to -3x minus 3. And the reason why I'm actually solving this and not just writing it like this is because I'm gonna, well, you know what? You could do it like this and you can solve and you can say this is -3x. Add 1 to both sides is that, and then substitute a -0.9, or you could do it up here, -0.9 plus 1, because then -0.9 plus 1 is actually pretty easy to add. It says calculator permitted though, so you could also use a calculator on this part. This would be -0.3, and then I would have to add 2 to that and get, what is this, 1.7? So right now, I found the equation of the tangent line, and then I used it to approximate f of -0.9. So this is approximately f of -0.9. And then it says, is this approximation greater or less than the actual value? I'm not sure yet, except for it says that f of x is concave down. And what I know about concave down functions is they look like this, and at any time I draw a tangent line, they touch at one location, but every other point is above the function value. So I'm going to say that this approximation, or I'm going to say this is an over approximation. And my reasoning for this is just going to be as f of x is concave down. Okay, so we answered all of that. The next one's talking about when is f of x increasing or decreasing, and give a reason. So I'm gonna give a reason before I even look at the graph. I'm gonna say f of x is increasing. If a function is increasing, that means its slope is positive. If f of x is decreasing, when f prime is negative. So even if I got something wrong now, I would have the points for the justification. So now I look at the graph, I see that it's f prime, so I'm thinking positive and negative. The positive is going to be from -infinity to -2. Remember, an x value to an x value. Less than 0, I can see it becomes 0 at x equals 1. So I'm going to say from -2 to +1, and then 1 to infinity. At what values of x does the graph have a relative minimum? So, or relative maximum. So what I'm going to say, f of x has a relative max. I'm given a graph of f prime, so I want to use it on my reasoning. When f prime changes and maximums happen, increasing to decreasing, so f prime is changing from positive to negative. So I gave my reason already, I'm good. If I look at the graph, positive to negative. So I'm reading left to right. I've got it right here at x equals -2. And then I don't see it any other place. So this occurs at x equals -2. For relative minimums, I'm going to say f of x has a relative minimum when f prime changes from negative to positive. And so then I look negative to positive. Okay, I'm negative, 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 negative. Uh-oh. Negative, 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 negative. There's a 0 here, but this never occurs. Even if this never occurs, you still have to give a reason if this question is asked like this. So I'm going to say f of x has a relative minimum when this changes from negative to positive. And then I'm going to say this never occurs on f prime. So f of x does not have a relative minimum. This is a totally valid question, but you still have to justify why there isn't one. Okay, so took care of that one. One more free response question to go. In this one, it says, use the function f of x to the 1/2 squared plus 2x minus cosine of x, and it's given up above. So I'm going to write this, f of x, to answer these questions. I want to find f prime of x and draw this on its axis. So f prime of x is going to be x plus 2. The derivative of cosine is negative sine. So this was negative, it's going to become positive. And then to draw this, I actually don't have my graphing calculator. Oh, hold on, let me check. Oh, yes I do. I thought I was without it and felt like, yeah, that was gonna be bad for a second, but don't worry everybody, I've got it. Okay, so what you're gonna do to draw this, we're gonna go to y equals, if you have a TI-84 or 83, and then I'm going to type in that x plus 2 plus sine of x. So I'm actually typing in the derivative. So you can kind of see this, there it is. And then what I'm going to do is, I'm gonna change my window to look like this one, and I can see this goes from -5 to 5, so I'm gonna push window, and I'm changing my x min from -5, x max is +5, and the same thing for with y. So y min, I'm gonna put -5, y max is 5. Just so it looks like the one over there. And so I see this looks like a line, and I wanna make sure too that my calculator, oh, somebody changed this. It says mode and it says in degree. And so what I wanna do, particularly if you are in physics class, this changes a lot. Make sure your calculator is in radians. So I just changed it by going into mode and then make sure radians is highlighted. Excuse me. Now if I graph it again, my graph looks really different. So I'm just gonna go and pick a few points because I don't want this graph to be perfect, but I do want these a few important values. So I'm gonna go second and then click on table. So it's above the graph. And I know at 0, 2, that was an important point. And I could also see, is there anything else of value here? I mean, there was, but 0, 2, let me go back to my graph again. I can see something's going on right here, and I couldn't tell by looking at my table. So what I'm gonna do is I'm gonna find the 0. The way that I do that, I'm gonna say second, calculate, and I'm gonna go to 0, and I'm gonna go to the left down here, which would be like just below the x-axis somewhere, to the right, and then it says, all right, push enter again, and I got the 0 is -1.106. So that means a -1 and a little bit more. Other than that, I'm okay with you just saying, you know what, I'm just gonna look at the graph and say, about what are these values? It does something like that. Okay, so I did this. At what values does the graph have a relative minimum? Give a reason for your answer. So because I'm using my calculator on this still, if I want to know relative minimum, what the College Board requires is that all decimals are rounded to the third decimal place. So I can see right here, wherever I found that 0, I'm going to do that same process again. That was at the point negative 1.10606. So I'm putting all of it 0. Just so I know that, that's where this is happening. Okay, so in this one, what values does x have a relative minimum? Minimums happen where the derivative changes from positive to negative. And this is the graph of the derivative. That's what we just graphed. So I'm going to say f prime changes from negative to positive. And I can see that this happens at x equals, and I need 3 places after the decimal, so 106. At x equals negative 106. Therefore, f of x has a relative minimum at that value. If I would have been asked for a maximum, I don't actually see one because there's no place where f prime changes from positive to negative.